tree diagram for probability trees. In this video, we will set up some of the tree diagrams so that we can practice for probability tree problems later on. For example, suppose we toss a coin. A coin has two sides, either head or tail, and then we roll a die. This die has 6 faces numbered 1, 2, 3, 4, 5, 6. There are two events here, tossing a coin and rolling a die. The event tossing a coin occurs first. To use a tree diagram, we would draw two branches for the first event because the first event has two outcomes. So we would draw two branches from one origin and we label this as head or tail. For the second event, rolling a die, there are 6 outcomes, and so we would draw 6 branches starting from head and 6 branches starting from tail. And so we would have 1, 2, 3, 4, 5, 6, and similarly 1, 2, 3, 4, 5, 6. This is a typical tree diagrams. Now, suppose we roll a die first and then we would toss a coin. Now this time, the first event, rolling a die, has 6 outcomes. And so to draw the tree diagram, we would have to draw 6 branches from the same origin, 1, 2, 3, 4, 5, 6, and we label these outcomes 1, 2, 3, 4, 5, 6. Then for the second event, tossing a coin, there are 2 outcomes when we toss a coin, and so we would draw 2 branches coming out from each of the outcomes for the first event, meaning head, tail for 1, head, tail for 2, head, tail for 3, head, tail for 4, head, tail for 5, and then head, tail for 6. The number of branches that we would need to draw first from one point depends on how many outcomes the third event consists of. If the first event consists of 2 outcomes only, we would draw 2 branches, and if the first event consists of 6 outcomes, we would draw 6 branches. In this case, there are 2 stages: tossing a coin, first stage, and then rolling a die, second stage. For the second case, the first stage is rolling a die, and then the second stage is tossing a coin. If there are 3 stages, then we would need to draw branches coming out from each outcome from the second stage, and so on. In addition to labeling the events, we also label the corresponding probability. So for example, when we toss a coin, the probability of getting a head is 1/2, getting a tail is 1/2. When we roll a die, the probability of getting a 1 is 1/6, getting a 2 is 1/6, getting a 3 is 1/6, getting a 4 is 1/6, getting a 5 is 1/6, getting a 6 is 1/6. The total of the number or the probabilities in the branches that are coming out from the same point need to add up equal to 1. And so in this case, there are two branches, one for head, one for tail, coming out from one point. This means the two numbers, the two probabilities, 1/2 plus 1/2, add up equal to 1. Similarly, the outcomes 1, 2, 3, 4, 5, 6, 6 branches coming out from the same point head. And so these 6 probabilities, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, add up equal to 1. Similarly, for the 6 branches coming out from the same point tail, the total of the corresponding probabilities need to add up equal to 1. This means this is 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. The probability from the second stage is a conditional probability. So for example, this 1, 6, it is the probability of getting a 1 given that the coin was tossed head. But tossing a coin and then rolling a die are two independent events. And so whether it is the head or the tail, it doesn't matter. The probability is still 1 over 6. Similarly, the number 1 over 6 in this brand indicates the probability of getting a 6 given that the coin is head. And again, that probability is 1/6. In general, we do not expect the two numbers to be the same. They are the same because getting a head and a tail are equal likely outcomes. The same thing, we don't expect to get 1/6, 1/6 or the same probabilities every time for each of these branches. In this case, they are the same because getting a 1 or 2 or 3 or 4 or 5 or 6 are equal likely outcomes.